Good evening, friends. I feel honored, privileged to introduce you to a thought leader, a distinguished personality from our Indian IT sector, Dr. BVR Mohan Reddy. So let's welcome him with a bouquet of flowers. He is the executive chairman of Cyient, which was earlier called Infotech Enterprises. Those who invest in stocks like I do sometimes, I remember that. But now the company is called Cyient actually. And company founded in 1991, he founded that. But one thing about the company is that it had been single-handedly responsible to put India on a global map for engineering R&D services. The company does engineering R&D services, technology based, and we earned a lot of name because of that. They have clocked so far more than $2 billion exports, engages 16,000 plus professional engineers. They have a presence in how many? 37 countries? 37 countries and about 70 plus development centers, So it's widely spread globally over there actually, And Cyient management also has been recognized, has been awarded a number of times. So for example, they have got Golden Peacock Award for Excellence in Corporate Governance from Institute of Directors. They got an award for National Award for Excellence in Corporate Governance by Institute of Company Secretaries. Also, company has been regarded as a leader in corporate innovation by Indo-American Chambers of Commerce. And well, all this was possible only because of the exemplary leadership of Dr. Mohan Reddy. Now, talking about him, and that's about his company, he's a double postgraduate. Postgraduate from IIT Kanpur and then from University of Michigan, Ann Arbor. He's got honorary doctorate degree from Andhra University, from JNTU, Jawaharlal Nehru Technical University of Hyderabad. He's got that. But what is interesting is that since I am alumni of IIT Kanpur, I know we honor distinguished alumni. He has been honored as a distinguished alumni. He's got that award from IIT Kanpur. He's also got Distinguished Leadership Award from American Society of Mechanical Engineers, Lifetime Achievement Award from Hyderabad Management Association. Like we have Ahmedabad Management Association, he's got a Lifetime Achievement from there. And of course, most importantly, Government of India, President has honored him as Padma Shri actually. Now, why he is here is, we are all from IT sector or interested in IT sector. He has been a former chairperson or chairman, they call it sometimes, of NASSCOM, National Association of Software and Services Companies. 2015-16 he was there. He also is a founding director of T-Hub, which is the largest incubator in India, for startups. And he is also chairman of the board of governors of IIT Hyderabad. He is known for his dedication and commitment to CSR, corporate social responsibility. His company has taken an initiative called Adopt a School, like AM is also doing, and currently Cyient touches lives of more than 15,000 unprivileged children. He has lately launched Digital Library Project to empower 25,000 children in rural areas to have access to the reading material and 50,000 community members. Immense passion for education for society at large and empowerment of unprivileged people. So this is there, and you may get people like that definitely. But one skill that I admire him for, because I heard him now number of times, very articulate speaker, content is very potent, lot to learn actually. In fact, we recently had today only we had a session from him at IIM, and that's how, I know, so in that sense, we are really very, very fortunate that he has taken one day out, has come to Ahmedabad, and is addressing us. With that, Dr. Pillai.
Thank you. Thank you very much. So, very good evening to all of you, ladies and gentlemen. Professor Jaju has always been very kind and very generous with his introduction. Thank you again, Professor Jaju, to be so kind to me. I spent considerable amount of my life in this industry, and certainly as sun starts slowly setting on me, I tend to spend more amount of time in terms of propagating a few ideas of mine and sharing some of my thoughts. And thank you, Ahmedabad Management Association, for inviting me this evening for this talk to you. I very consciously decided to caption my talk as the tech industry, the challenges and opportunities. And why do I say that? Is I think the world is going through an unprecedented change at this point of time, with largely driven by 5 different forces. And these, in terms of pace and scale, have been never experienced in the past. The first is certainly you see rise of emerging economies, and largely led by China. China no more is an emerging economy, but it's risen to a level where probably it's second largest in the global GDP. And the second one that we are seeing is the aging population, especially in Europe, and some of the emerging countries like India. We have a major advantage in terms of demographic dividend. And a third force, I believe, is the disruptive technologies. Technologies have never been as disruptive as they are as we see currently. And then the fourth one is that on one side, we see there's an integrated world. As my good friend Nicholas Negroponte from MIT Media Lab says, the division between the countries are like lines etched in sand, because you don't have that any longer. We're all connected together. It's one single world that we all experience at this point of time. And finally, at the same time, we also have fairly serious geopolitics that are going around. You saw even in the last few days, again, after 6 years, I believe, the US government shutting down. And that was again politics, because Trump was not getting money to build a wall in Mexico, whereas Democrats were trying to say some of those illegal descendants, they're not illegal immigrants, they are descendants of illegal immigrants, have to get a valid status. So there is, all of you heard and experienced all about what's happening with Brexit at this point of time. So it's a combination of these 5 unprecedented phenomena that is changing the world. I'm not going to be spending so much time on all the 5, but I just picked the center one, which I think I'm more familiar with, is the power of disruptive technologies. If you look at technology per se, it's not something new to mankind. Since the late 18th century, mankind has always been experiencing technologies of different forms and different intensity. So the first industrial revolution brought in mechanical production. That's when mankind decided the power of water as well as steam. Pardon me, there's a small distortion that today should have come here. It's a PowerPoint flaw. But then the second part is the second industrial revolution brought in more of how the division of labor could happen, which is to do with assembly line operations. Largely also credited to Ford Motor Company. Henry Ford decided to build what is called as the T assembly line, mass production of automobiles, except for the fact that he said that you can ask for any color car so long as it was black. That's what Henry Ford said. But then he still made cars accessible to people. I actually have a picture of taken of the 5th Street in New York from a vantage point. In New York of the 5th Street on the 5th Avenue, somewhere in 1905 or 1907. And the picture shows the street is full of the horse-drawn carriages, except in one corner you'd find one car. And 10 years later, the same photograph was taken. The street was full of cars and just one horse-drawn buggy. That's what it was. It's a real-time picture. So that reflects back how the advancement happened in those 10 years. Not necessarily horses were killed or horsemen disappeared from the world. They will come to that. They decided to do different skills. But the fact is that, that was a transformation that Henry Ford's assembly line manufacturing brought into the auto industry. The third industrial revolution was more in the 1970s. And we will talk about that a little more, largely driven by ICT, that's information communication technologies. And certainly we brought in more amount of automation. No longer people had to do bookkeeping, so they did not do inventory control. These are some of the applications which started coming into play. Or you don't need to do payroll processing by writing ledgers and so on and so forth. They were all automated. Automation came into play. But the most interesting one that I find, and in some ways in several forums I keep saying that we're all very lucky people, especially the youngsters that I see in front of them, because they're born at a time when the industrial revolution is at its best. People like me, as I said, sun is setting on us, it's not too far away from where we are. We don't feel sad about it, but the fact is that we are also experiencing this revolution that's happening. So the fourth industrial revolution is actually very difficult to even pinpoint where exactly or when it exactly started, because it is evolution from the third industrial revolution of ICT that moves into the fourth, and actually to the extent the Germans call it as Industry 4.0, the fourth industrial revolution. And what we are seeing is the merger between the physical world, the digital world, and also the biological world. All three of them will get together at this point of time. And that is going to provide amazing disruption in this world. To the level that the Industry 4.0, you look at it, Henry Ford said, as I quoted, that I can produce any color of car so long as it's black. Whereas now, you can produce any type of car, any shape of car on an assembly line itself. That's the level of order, because you can look at the order position, you can get the parts come in time, only exactly to build your car at that point of time, still in an assembly line operation. You can't say it's a custom built car. So the result is there is marvels of changes that are happening. So let's look at what is driving this change. What is driving this change is, to me, there are four different factors. The first and the foremost is the computers. And just not the computers, but I think the pace at which these computers are becoming cheaper, faster, and smaller. I know some of you could have been familiar with this name called Gordon Moore. Gordon Moore was a co-founder of Intel Corporation. And what did Gordon Moore do? In 1976, I believe, he came out with this great proposition which said that in every 18 months, the number of components that can be placed on a wafer will double itself. That's what Gordon Moore said. And as a result of that, the power of computing will go up. The size is coming down because you're putting double of them. He said cost will also come down. People said in 1976 that Gordon Moore was a crazy man. He didn't know what he was talking about. In 1996, 20 years later, people reviewed what Gordon Moore said. And it was proved that he was wrong, because it was not taking 18 months, it was taking less than 18 months to do this. And we thought it would slow down even after 1996. It hasn't. It relentlessly continues to improve. Professor Jazu was kind enough to talk about my stay at IIT Kanpur. And when I went to IIT Kanpur in 1972, that's when I went there. Not many of you would have been born, except a few friends of mine who were in the front row, and including Professor Jazu, I'm sure. I saw the computer center. People told me that was the best in the country. There was nothing short of the best in the country was IIT Kanpur Computer Center. So there was this huge building, and the computer was located in a room which is almost 4 times the size of this room. That was the computer center. And more interestingly, on the lighter vein, I keep telling people, I also saw this very nice fountain in front of the computer center. And it used to be a water fountain, water dancing up and down. And I used to tell people, what a marvel of an architecture this is. Water and this building, humongously life, very impressive. I'm sure Professor Jazu and some of your IIT Kanpur alumni are familiar with this. But the truth was that water fountain was there to cool the computer center. The water was all being, that is the amount of water was being used. And what was the power of that computer? It was less than what many of you have in your pockets or in your bags. That was the computer it was. So look at the transformation that we have seen from 4 times the size of this room, from a water-cooled system to every one of you have a more powerful than that computer. That's one phenomena that has changed the world. The second one is that we did not have connectivity between people. To get a phone line in this country, in my generation, it used to take 10 years. I'm sure some of you are familiar with this, so they're all nodding with me. Thank you, sir. And actually, some of our foreign customers get very amused about this. We tell them that it used to take 10 years. And then actually, in some of our people whom we used to hire, for some of the managers, this used to be one of the perquisites. You will be provided a phone at your home. So people say, what is this about? I'm sure youngsters like you will all laugh at me and smile at me. But that's how life was. So we're not at all connected. There's something called a landline that's there. Tell me, how many of you have a landline at home? Maybe a handful of them, right? But not many of them. Actually, if you go to the Western world, they don't have landlines anymore. Because I have my personal phone. Why do I require a landline further than that? So therefore, if you look at the connectivity, that has also grown exponentially. The connectivity between systems was there to a small extent. There used to be one port called the RS-232C port, if you're familiar with it. There used to be a jack, you push it into a computer, it used to get onto the telephone network. They said that was not good enough. Then they came out with something called an Ethernet, which was 2 megabits per second, local area network, it was LAN. What are we doing today? You can get a gigabyte of downloads and uploads in fraction of a second. And how many people are connected? So say, Mr. Reddy, you're wrong. It's not people who are getting connected now. It is people and things which are being connected together. And what is the number? Our forecast right now says by 2020, you'll have 20 billion people and things which are on the name network talking to each other. That's the power of networking that came in, connectivity. And a third one, which is another very fascinating, interesting thing, is that there were this very ugly looking sensors that were there. They were large actually. People said, oh, I have a sensor which can detect the oil flow. Big box on top of a tube that used to have oil flowing. What was the purpose of that? It is all about detecting oil flow. Or they said, oh no, I can also detect the heat, temperature. There was a temperature sensor, which is another box that was there. So all that has also become miniaturized. All that has also become, for lack of a better word, I'll say dirt cheap. And it has become extremely powerful. What can you measure at this point of time? You can imagine what it is, and you can measure them. The most fascinating example, Professor Jaji will pardon me, I've been using a few examples of this nature, is the last one that I saw, which is very fascinates me, I'm sure it will fascinate you too, is my wife is a borderline diabetic. So she told me about 8 weeks back or so that her doctor said he's going to put a wearable on her to measure her blood glucose level on a continuous basis. As always, given my other priorities of life, I said, oh, go get it done. So I come back in the evening and ask her, saying that, where is the wearable? She says, it's there. So I said, where? So it's right, she wears a blouse, so it's underneath her shoulder blouse. And then she said it was like, a injection prick, 2 millimeters by 4 millimeters in all. And it's like 1 rupee coin actually, the plaster. It's so thin that she did not even have to loosen her blouse. And what is it doing? For 15 continuous days, every 15 minutes, it had a recording of the sugar levels, blood glucose levels. Again, the size was 2 millimeters by 4 millimeters. That's a sensor that now does all analysis with blood. That is the way in which the sensors have progressed. Now come to the fourth dimension and my last dimension. These sensors are now putting in enormous amount of data. We said, oh my God, I sold computers, and you'll be very amused about this. I used to sell computers for HCL at one point of time. And what was the storage capacity? 256 kilobytes for an 8-inch floppy. That was big storage. 256 kilobytes I'm talking about. Or 80 kilobytes is exchangeable format. That is smaller floppy disk drive. That is 5 1/4 inch. That was what the storage capacity was at that point of time. And that was the data that was there. Now, we heard about kilobytes, megabytes, gigabytes, terabytes. Now they're talking about storage which is nothing short of petabytes. That's the amount of data that's coming in. Now, you look at the data that's coming in and say, oh no, this is all crazy people creating data. No, the data, then you now couple it back with the computer. It gives you enormously meaningful results when you then supplement this with intelligent algorithms. Algorithms was possible in the past, but what would it take? It takes 6 hours to give you a result. What would you wait for? The same blood sugar numbers would come by, and then the algorithm would run somewhere else and come back to you, give results. You're not there. Whereas today, what is it? This chip, back again to the story I was talking about, the blood sugar levels of my wife. The doctor takes it out, puts it back into the system, and then you superimpose on top of it how the pattern, your food habits, your lifetime habits, when do you sleep, when do you go for an exercise, and so on and so forth. You get amazing results as to what exactly you eat and what the sugar levels you get. To me, life-changing, honestly. That's what it is. So therefore, you look at the technology play that's going on, and it's all because finally it is coming down to digital. A computing world, connected world, sensor world, algorithms, which is all digital. It's all binary, zeros and ones. Even if you look at blood glucose, that's not binary actually. It's an analog signal. The analog signal gets converted to binary. So we now have mixed signals, as we call. That's a big opportunity in terms of business. Let's move on further. So, but what is amplifying this acceleration? There is this technology being there, but we see that there's more amount of acceleration that's happening. Is the first one is, we talked at length about cheapness of technology. But then the other thing that's happening is that the comfort with technology is growing dramatically. A good example of mine, of the recent past again, my wife and I went for a short holiday to Uzbekistan. We went, we want to take a week off, so we went there. And I suddenly saw in those mosques and madrasas and minarets and so on and so forth, 2 young kids chasing each other, playing, and they were getting a little, I was getting curious about why they were running behind each other and stopping and doing something. And I watched what it was. Actually, there's a 2-year-old who's chasing another 2-year-old, trying to take pictures using a smartphone. So I took a video of that too. So it's there in my camera now. But the first time I saw a camera was when I was 20 years old. First time I owned a camera, I was 40 years old. So look at the children that they have. The access to technology certainly amplifies the ability to use technology. Or the other one that we also found is that there is enormous amount of competitive advantage for technology. A favorite example of mine is there is an oil rig off Iceland for GE. There were 200 people who were stationed on that the oil rig. And it was extremely excruciatingly difficult proposition, and still it was costing them a lot of money to maintain it. They rejigged the whole jig now using IoT, Internet of Things. Basically, we'll come to that in a moment, but more to do with sensors. And what is it? They invested about $100 million, and what they got in return in the first year is $1 billion. So that is what is amplifying it. Further is that we also see multiplier effective technologies. A good example is Uber and Paytm. What is Uber? Uber is a platform which makes customers and drivers meet each other. That's by definition what it is. It's not a taxi platform. You're in need of a ride, it's a ride sharing platform. And there is somebody else ready to give you a ride, you go and pay for it, you do that all right. But I don't know how many of you use Uber or Ola. I don't use it in this country all right, but I use it extensively, especially in large cities like New York or San Francisco. I actually get thrilled using that platform because it's so easy to do. It's no more, you just go and ask for a ride, and then the guy comes up and the door opens in front of you, and then he just says, Mr. Reddy, confirming you're the right passenger. Nobody else is jumping in instead of you. Nothing more than that. And then he also knows where you're going because you're already pinned the address to him. So if you're only curious to say how long it is going to say, he'll answer you saying, Mr. Reddy, 35 minutes. Then he would pause and say, I have a question for you. What is it? Do you want to use the south entrance of the Westfield Mall or the north entrance of it? I say south entrance, silence. 35 minutes, door opens again, and before you say thank you, and that's all done. And then you see a beep signal coming on your phone, and what is the beep signal all about? It debited your credit card already. That's what it did. But so therefore it debited your credit card already. So with Paytm, that's a payment gateway. Uber would not have been successful without Paytm. So look at how the technologies play on each other. Or the other way around is true. Paytm would not have been successful without Uber. And the other one is that we also see this tremendous amount of globalization of technology. At one point of time, we used to say access to technology was limited to the haves. There was a difference between haves and have-nots. They are developed countries versus undeveloped countries. That's not true any longer. Everyone has the same access to technology. So as a result of that, it's amplifying itself. And as a consequence of this, with technology becoming so easily accessible, so cheap, it is globally there, innovation is becoming a mainstream for everybody. What is innovation to me? Innovation is question the status quo, start taking risks in life, pursue your idea, have self-belief, and work in teams. That is what I think is further amplifying this innovation coming in, the mindset of people saying that I can experiment, I can change, the society is changing. And that is leading into yet another thing called entrepreneurship. And the sum total of this story is that, well, technology is very disruptive, but it's being amplified by other factors which are accelerating this technology. So what is the impact of this digital revolution? Nothing is being saved. Whether it is business, it's society, every aspect of our lives have changed. I keep saying the way in which I dine has changed. I can think about what I eat much before I go to the restaurant. Actually, somebody was showing me a startup application in the recent past where I can take the menu card, take a picture of it. It's an app that's there. And it will tell you what is gluten-free and what's not gluten-free. It will rate each one of the dishes that are there. So therefore, it's not, the whole life has changed because of technology. And then we also have changed our behavior. Gentleman here and I were having a conversation how life has changed. We have a different viewpoints, all right. But I think, happiness is disappearing. I don't know at this point of time. I feel very happy about myself, dabbling around with technology constantly. But some people might feel, no, this is not what's true. And then we also see change in leadership and age-old importance of which country you belong to doesn't hold good. I don't know how many of you are watching this. There are very good startups that are coming out of Africa right now. Amazingly good. Poverty-ridden nations they are, but still the brain is the same. They might not enough to eat, but they have the ability to think. And that's what they're doing at this juncture. And we are seeing convergence of technology, and certainly the bottom line is the impact of digital revolution is one other thing that I, in the lighter sense, tell you this. This is what the man was in 1990s. By 18 years later, this is what has become, right? And this was the TV in 1990. Look at the TV, what has become. But on the more serious note, I believe in 1818, 200 years back, the lifespan of a human being was 35 years. And in 2018, it's become 75 years. Or I'm getting my numbers wrong, I'll tell you. 68, 69, approximately. So, in India, worldwide, global average is 75, I believe. It moved from 45 to 75, 30. In 30 years' time, in 200 years' time, it moved up by 30 years, which approximately gives you a number. I know the other number right. I got this one wrong, I think. Is approximately for 17 years of research, longevity is increasing by 1 year. That's what the number is. But the more interesting one is, if 1 year of research will increase the longevity by 1 year, what happens to all of us? We'll live forever, maybe we'll require more spare parts on our bodies and so on and so forth. But as a result of this, there is disruption in every potential industry. And this is a good example of mine. What comes to your mind when you think about an automobile? What is the biggest part in an or a subassembly in an automobile? Engine. Huge, absolutely. You open the bonnet, the car is full of one thing called engine. And the way in which they pack them, I drive a few German cars, so therefore you just lift the hood of the engine, there's all hood of the car, you'll find it's nothing but engine. And then I'm a trained mechanical engineer. I got my degrees in mechanical engineering. And what is about is we learned about what is called as a rack and pinion arrangement. What does it do? It actually translates the rotary motion of the steering wheel into a lateral motion of the wheels. The wheels move this way, right? That's lateral motion. Whereas the steering wheel moves this way. To convert that, so there's a rack and pinion arrangement. There's a gears that go in there. Or a third one, if some of you are familiar, there's something called differential, which sits underneath the chassis of any automobile. It's a huge mechanical structure. What's the reason for that? Is because when you start taking turn, the inner wheels of a car or an automobile have to rotate at a lower speed compared to the outer wheels, because the circumference is larger compared to the circumference inside. So that control comes from differential. You go and look at this frame that you see at the bottom. It's nothing but a Tesla motor car frame. All have disappeared. There's no engine. There's no rack and pinion arrangement. There's no differential. What has happened? Elon Musk decided to put just 4 motors in 4 wheels. And he said, instead of having an IC engine or a power plant here, we'll get power generated somewhere else. And then I actually, very honestly, very curiously, I was looking for where the batteries are. There are no batteries also left behind. Because what he did was, he energized the floor plate. The car has to have the floor plate because you got to sit on top of it. Something has to be there. And that floor plate is energized at this point. That's the battery that discharges into the 4 motors. And so then you can rotate at any speed, it can turn any way you like. So all that has disappeared. Look at the disruption that happened. Look at one more example of mine, and I'll move on thereafter. Here is the Apple iPhone. Actually, it has got about 1, 2, 3, 4, 5, 6 layers, all packed in that 10 millimeter thickness. Technology which is miniaturized, and what does it have? It's just not phone. It has music, it has television, it has movies, you can do shopping online. You have a clock, you have a calculator, you have an alarm. You have GPS, you have maps. You have Kindle, you can read books. Actually, there is a number which says, this I believe in 1998, if you look at those features on the left-hand side of the screen, or to the right-hand side of the screen, whichever you like, that used to cost somewhere in the close to $1 million in 1998. if you wanted all those features, they were not in one gadget. And now it's down to as much as $500. That is the power of disruption that's happening in electronic industry. So what is the opportunities that are there? Let me look at them. So these are some of my favorite topics that I have. These are the new technologies. We've identified some of them. When I say we, I'm referring to NASSCOM. Artificial intelligence, wearables, drones, robotics, 3D printing, virtual reality. There are 2 more of them. 8 of them which are on the hit list at this point of time, where we think they'll make a tremendous amount of impact on all of us. And if you look at some of these, to me, it's only your imagination is a limitation in terms of the type of application that they can be put to. They're extremely exotic applications, nothing short of that. So underlying this, of course, in each one of them, artificial intelligence, for some of you who are not aware of this, was extremely dominant at one point of time in 35 years back. People said the world will be ruled by AI. It didn't happen. So people are now again the same mode saying that no, Mohan, it won't happen this time either. And I'm saying, boss, the world has changed considerably, because at that point of time, actually I used to be associated with a very world famous computer scientist called Dr. Raj Reddy. Raj was Dean of Computer Sciences at Carnegie Mellon University. He's a Turing Award winner. He's a Centre Mondial gave him Legion of Honor, French Honor, and so on and so forth. Amazing personality. Raj used to talk to me 35 years back about a driverless car. But then both of us used to finally come to a conclusion that the amount of computing power that will be required for the car to be driverless, there'll be a truck which is a 10-tonner which has to be driving behind the car. That's the amount of computing power. World has changed. Today you don't require that truck behind you. So the result is that because of that, all these today are certainly creating what I call it as a VUCA world. Volatile, uncertain, complex, ambiguous world. Let's look at a few examples quickly. IoT, as I said, it's doing so many things at this point of time. But more interestingly, one application, I talked about the blood chemistry all right for sensors, is today there's an aircraft engine from United Technology or Pratt & Whitney, which is called the GTF, Gear Turbofan engine. We were very involved with this customer of ours in terms of developing this engine. We now have 5,000 of these sensors in these engines. And on a flight, it does about 10 gigabytes of 10 gigabytes of information per second it generates. What is it been a position to be able to do at this juncture? We can monitor the health of this aircraft engine when it is airborne. So you can name them now, just not aircraft engines. We have an application with Schneider where we are now doing elevator monitoring for them. We have an application with Bombardier where we monitor their trains. All of them built around sensors, communication, computing, algorithms. And as a result of that, what is the final benefit that mankind is getting? It's become safer, it's becoming cheaper to travel. And the second application I have is about robotics. Very traditional thinking about robotics used to be that they were used for applications which were in, say, in a factory floor, or it's a hazardous material handling. Paint shop was a very good example of using the robots. But today, they are in very nicer applications which are again saving mankind in terms of surgeries. A doctor was explaining me the other day, he has one of these urology surgeon who does prostate, one of the best guys I know in the world. He was telling me that the movement of 10 millimeters on his hand will only move the knife by 1 millimeter. So look at the flexibility that he has in terms of movement. He looks at the training that goes on, the specialized, and then what happens further with these equipment, which is really fascinates me, is that they're constantly monitoring your skill level. Not that they're just leaving you apart, you're assisting you, but more interestingly, they monitor and rate you how well you're doing every surgery. So that is the power of technology, and that's the type of application that are there. Look at the other one, the drones. The favorite application of mine is that drones, agriculture, we're doing something called precision agriculture at this point of time. What do? Is you fly drones, monitor the health of the crop. If there's a pest, there's a second drone which is flying behind it and spraying the pesticide precisely on the leaf which has the pest there. What was the poor farmer doing so far? He ever saw a pest in one corner of his field, he used to do pesticide all around. Savings, I believe, is somewhere between 60 to 70% of pesticide usage. It certainly makes the world much more environmental friendly world. So certainly technology is a very positive spinner for me, or you get down to 3D printing. And 3D printing has enormity in terms of applications, leaving apart the rest of the stuff. And as a result of that, what we are seeing at this point of time is even biological parts are replaced. So I go back to the example I gave you. If research will expand, 1 year of research will give 1 year of longevity to mankind, you'll require more spare parts. And I think technology is there providing those spare parts. Right now, dentures are being 3D printed precisely to your requirement. Knee replacements are all in United States, are all done by the 3D printing machines. And they can do, actually, the whole of design concepts have changed considerably. If some of you are mechanical engineers, especially, you'll understand, you look at the design that we did, they had to be straight lines. Why? Because it was easy to produce. You take it to a press shop, press cannot do a contour which went like this and came back like this. It can't do that, right? Any of those French curves, as I keep calling them. It was not possible for them. Whereas now it's possible because you can deposit metal where exactly it is required. So therefore, the sum total of the story is imagination is a limitation in terms of your application. That's number one. Number two is technology does good to us. Healthcare, innumerable number of examples. And other sectors, especially in India, we think that the impact could be on financial inclusion. An example I have is that in the past, the agriculture sector, the farmer, if he used fertilizer, it was subsidized by the government, but subsidy was not paid to the farmer, it was paid to the fertilizer company. And as a result of that, government felt, and I think it's true, there's a sizable amount of misuse that was happening. And now they have something called direct benefit scheme, which is basically through inclusiveness, they brought financial inclusion. So directly the farmer gets the subsidy now. He buys a urea for 700 rupees a kg. At the moment the transaction is done, the 200 rupees from the government is also moving into his account. So look at the benefits that are coming in, whether it is healthcare, it's financial inclusion, agriculture, or in educational skilling. So what I keep saying is technology is doing good, and also is good for India because it could provide a social equalizer. And it can definitely, I think what we need in this country is frugal innovation, and certainly we need more amount of complex innovation as opposed to very peripheral innovation, as I keep calling, because I also dabble around quite a bit on the startup community. I have a fairly large number of companies where I've invested, not for any reason to promote them, not to lose my money, also make money out of it. And I have some very good stories to talk about it. I'll talk about it later. But the result is that, but you look at Indian startups more often than not, they'll all say, I'm doing a food tech startup. What is food tech startup? You just get food from restaurants and distribute it to customers on the other side. There's no technology in that. If you want to get them to them, I have another startup which has just got acquired after 18 months, which is more to do with health ECG equipment using technologies, which is using IoT. It got 5x multiple in 18 months. That's deep tech to me. Let me move on. I'm conscious of time. It's 7:30, so I need to quickly close. So technology disruption, what is required is, you have to challenge the status quo. Otherwise, you will get disrupted. Number of examples being there. Where are bookstores? They've all disappeared. Where are yellow pages? There's something called marketplace. Now there's nothing called, you have video recorders, and I keep them anything static. It's all streaming in whenever I need. And cars have become ride sharing. Rooms have become Airbnb. That's the change. And one concern several of you could have is saying that what would happen to jobs then? Certainly, yes, jobs have changed. Over a period of time between 1850 and 2000, if you look at it, even in a country like United States, 200 years back, 80% of the population were dependent on one avocation called agriculture. Today, less than 3% of United States is dependent on agriculture. So the other jobs have got created as a result of that. So therefore, my point is that don't get worried about jobs being replaced. Jobs will definitely get created. But you need different type of skills for these new jobs. The same old jobs, same old skills will not be there. I belong to a generation where we thought, you did engineering for 5 years. It was not 4 years like what it is today. It was 5 years in my generation. And we said, that's an investment for your lifetime. I'm done, boss. I became an engineer now, a strong engineer. But what is it today? No, wait for 2 years, man. What you learn, basics will still be there. Like, I can tell you about enthalpy and entropy in heat transfer today. Those are fundamentals of engineering, heat transfer. But then you now look at what my automobile knowledge is. If I say, no, I will only know about IC engines and not learn about fly-by-wire that goes on these cars now, then I'm obsoleted out. So therefore, what we'll see is that tremendous amount of shift in technology, and you need to learn new skills. And businesses also will change. The organizations in the past were factories, offices, assembly lines, division of labor, span of control. That's what companies were. What do we see as a future? Distributed networks, agile teams. People and smart machines will work together. That's what the future is like. And we'll also see that the executive team's focus used to be more of operational control. I want the numbers to be right. No, that's not what it is. It's now about unlocking the value for an organization. Capital assets, people used to build buildings and everything was asset heavy. Now it's all asset light. Processes have become intelligent. Leadership has become networked. Revenues are subscription and relationships. People now are becoming more independent workers. And I think that the other thing I just want to spend a little time is in this word called deep generalists. You definitely need to be a generalist. I gave you a Tesla car example, automobile. You look at the technologies that are there. The technology is still mechanical. The frame is mechanical. The wheels are mechanical. Shock absorbers are still there. Though I think the last I read was even shock absorbers will disappear, I believe. Actually, they go into the rim of the wheel. That's how the shock absorbers will be. They won't be isolated as taking the shocks on the four edges of the car. Or therefore, then you have electrical work, the motor, embedded software, actual software, internet connectivity. Actually, if you look at a Tesla car, there are no more knobs anywhere in the car. There's just one control panel in front of you. And touch screen control panel. Screen up, screen down, lights on, lights off, anything that you want to do. It's so automated, absolutely. So you need to know those technologies. That's what, so therefore, you need to be a generalist. You need to have several things. But in every generalist area that you touch on, you have to be deep inside it. Let's move on. So what are the challenges? What I'd like to leave with you is that status quo is not good enough. Don't think about incremental changes. Think about exponential changes. That's what life has to be all about. You have to develop the culture of entrepreneurial thinking. And I think I briefly mentioned learning is no longer a journey with a destination. There's no destination. It's a continuous learning that you need to do. And we're doing a lot of work in this area for NASSCOM at this point. I personally am involved in a major project called Skills of the Future, where I also get very perplexed with some of the things I learn myself. Where what is happening is we got a learning management platform now, which is being done by a company which is associated with us, where actually the content can get customized based on what your current skills are and also what your future goals are. That's fine. It's not static. It doesn't say one day. Then you start learning every day after you finish a class. You take a question paper. Based on it, your next learning could be coming up. So, for example, there could be two people, you and me, and we could have the same skills today. We all have the same aspirations tomorrow. But it doesn't mean the content will be the same between both of us. It changes based on the pace at which we are learning. That's how the challenges are, And therefore, so please, I think that people ask me this question, how do people become innovative? To me, first step, challenge the status quo. Why this way? Why can't it be different? So that is how you start becoming innovative. The opportunities are plenty. We belong to a country which has got the democratic dividend. We are hoping that India will become the global innovation hub. We're seeing a lot of change, lots of opportunities coming in. The biggest opportunity, of course, is that with 1.2 billion people in this country, with a $1.3 trillion economy that we are, that itself is a big opportunity for us. Entrepreneurship, let's skip, and then finally conclude by saying, world is changing, innovation is the new regime, and technology is always for good. So thank you very much, ladies and gentlemen. Thank you.
Okay, thank you, Dr. Reddy. I think it was very interactive, very informative. But before we close this evening talk, on behalf of AMA, would like to give you a special memento to you, sir.
Thank you. Thank you, sir. Thank you very much. Thank you. Thank you, guys.
So big thank you to all of you coming in a big numbers. Thank you, Professor Jaju, also bringing Dr. Reddy here. So we close the evening talk here. But before you leave the room, I think we look forward for your feedback also. The feedback form is there with you. Thank you so much.
Thank you, Professor Jaju.